Hello, everybody. I am Jagdish, lecturer from Srimati LU Government Polytechnic, Assam, in the Department of Mechanical Engineering Machine Tools Department. I am taken third semester subject Principles of Machining Process, Unit 1, and in that session I am teaching session 5 and 6 regarding taper turning methods. Taper turning means reduce the diameter from one side to the another. There are various types of taper turning methods are there. Fundamentally by farm tool method, taper turning by attachment method, by taper turning by tailstock method, taper turning setting one method, and a compound rest method. Among this, these are the five methods are used to turn the taper at various stages, at various operations, at various levels. By setting over the method is suitable for a small tapers, and in this type tailstock is moved from one side to the another side. In the compound rest method, compound rest slide is moved to the other side by using some calculator by angles different of degrees from calculated by small diameter and large diameter. And another one is by farm tool method. In this method, taper turning is moved from one side to the another. In a farm tool method, by an experienced persons can do the can perform the operations is by a skilled worker can perform the operations. Another one is in a taper turning attachment method. In this method, taper is reduced at various stages. In this method, very long taper can be turned. These are the different types of taper turning methods, and they are employed by different skilled persons at various stages and in various operations. These are the once again I told first one is in a broad nose farm tool method. Another one is in a tailstock method by selling the compound rest method. Another one is in a by taper turning attachment method, and another one is in a combining longitudinal and cross feeds in a special lathe. Special lathe. Another topic is by taper turning by setting over the tailstock center method is suitable where work is held between the centers. The workpiece is rotated at an angle to the lathe axis, and the tool is fed parallel to the axis. This is very important in this turning method. Desired conical surfaces can be obtained. Use a turn small external taper can be suitable for a long workpieces in this type of taper turning method. And another one is to calculate the set over distance is that is the L into D minus D over 2L. L is length of the taper and the length of the workpiece, and is a smaller diameter, and another D is a larger diameter, and 2L is the length of the taper can be turned. These data can be used to calculate the set over the tailstock method. Another one method is a taper turning by compound. Next one is a taper turning by compound rest method. In this method, the workpiece is rotated at the lathe axis, and the tool is fed at an angle to the axis of rotation of the workpiece. Tool is mounted on the compound rest. In this case, this is very important. The tool can be fed at an angle to the compound slide as the compound rest is mounted at half taper angle, and this the half taper angle can be calculated at tan alpha is equal to D minus D over 2L, and this is also suitable for a very small length tapers. Another one method is these are the common types of taper turning methods usually employed in our machine shops. Another one, next one is next topic is goes to the thread cutting procedure. In to cut the threads in a lathe, the following procedure is adopted. The first step, the excess material from the workpiece is removed. Means on the job or in a workpiece, the total excess material can be removed first of all. Next, change the gears of a correct size. This is calculated by different by the what type of thread can be produced, and by using the different calculations, the gears can be the gears can be corrected to the suitable gear wheels, and that is fixed on the in the idle in the gearbox chamber. Another and proper cutting tool, V cutting tool is selected. The next one is the top of the tool nose should be set at the center of the workpiece. The next step is the spindle speed reduced to one half of the or one fourth of the speed. Next one is half nut is engaged. It means to carry the threads, and the depth of cut is applied perpendicular to that. After helical groove up to the end, tool is quickly withdrawn. Tool is brought back to the starting point and starting point and repeat it. Next one is these are the in this session's topics by various taper turning methods and thread cutting procedures. That is the reduce the diameter from one side to the another side. That is called a taper. These are the common types of once again we repeat it. The different types of tapers are farm tool method, compound dust method, setting over the tail stock method. By combining feeds means by an experienced persons can turn the taper without using the other data. So experienced person automatically by using the longitudinal cross feeds taper can be achieved. Another topic is a thread cutting procedure. To form the threads or to produce the threads, the following procedure is important, and this is followed. This is the conclusion of this session. That is the taper turning methods and the cutting of threads in different ways. That's all. First topic. That is first topic. That is about the first topic. That is about the in section 1. Another session is next session is a nomenclature of a single point cutting tool. Wherever you go in a workshop, they to produce the components. Single point cutting tool is very important. That is a V tool or a single point cutting tool. To regarding that, we are discussing in this session nomenclature. Nomenclature means different parts of that single point cutting tool at and different angles. Cutting tool nomenclature means systematic naming of various parts and angles of cutting tools. And figures illustrates the different parts of a single point cutting tools, and it shows. First one is a shank. Shank is the portions not ground to form the cutting edges, and it is a rectangular in the cross sections. And the next one is a face. It is the surface against which the chip slides upward. Another next one is a flank. It is the surface which faces the workpiece. Heel. Heel, it is the next one is a heel. It is the lowest portions of the side cutting edges. Next one is a nose. It is the conjunctions of the side and the end cutting edges. Next one is a base. It is the underside of the shank. Next one is a back rank angle. And next one is a back rank angle. It is the angle forms the face or top of a tool has been ground back at an angle sloping from the as shown in figure. This is very important to turn in the machine shops or in the workshops. And different nomenclatures are parts of these are the shown in figure in 3D sketches. That is about the front view, side view, and in a top view. These are the different nomenclatures of a single point cutting tool. Wherever in the machine shops, first of all, the tool, single point tool is ground at a proper angle to produce the required shape or to produce a required component. That is very important. That is very, very important in a single point cutting tool, and it is suitable to produce a required component to perform the different operations at different levels at in a different stages. Otherwise the products can be rejected or component cannot produce at a particular or in a proper way. Next one is a part of a side rake angle. Side rake angle, and another one is a side relief angle. Next one is an end relief angle. Next one is an end cutting edge angle, and another side cutting edge angle, lip angle. These are the different angles are mainly maintained or followed in to ground the single point cutting tool at various stages, and at various levels. These data can be very important in a single point cutting tool to produce at various stages. These following data is very essential and important to ground the single point cutting tools. Next one is next we want to cutting uh, next one is next next we move on to next we move on to the one minute I will show this slide. Next one is a cutting speed and feed and depth of cut. It is also important. These are the cutting speed, feed, and depth of. These are the important factors followed in the lathe cutting operations, or in the, that is particularly refers to the lathe only. Cutting speed. Cutting speed is denoted by a letter V, and V, it is the speed at which the metal is removed by the tool from the workpiece. Means the tool can be set to watt speed, that is in RPM, in revolutions per minute, and it is calculated by an angle. It is calculated with speed. Cutting speed is equal to V is equal to pi d n over 1000 meters per minute. It is very important. Cutting speed is an 600 to nearly 2000 RPM are maintained at various metals at various stages. Next one is a feed. It is the distance of the tool advances for each revolution of work. Means it is what material can be removed is given by in the for terms of a feed. Is called to be a feed, and it is expressed in millimeter per revolutions. Means it is the distance of the tool cutting tool advances for each revolutions at work. Another one is depth of cut. It is the perpendicular distance measured from the machine surface to the unmachined surface. Means before material and machine can be run, and after that what depth of cut can be given, that is measured. That is an D1 and D2. That is can be calculated by depth of cut in a lathe is D1 minus D2 over 2. D is diameter of a workpiece before machining, and D is after machining, and divided by that the depth of cut can be calculated. Depth of cut can be calculated as shown in figure. How is workpiece works: depth of cut, machine surface, chip, depth of cut, cutting speed, and chuck. Next one is next topic. We shall move on to types of chips. Types of chips in lathe to remove at the time of removing the material. There are three types of chips are produced. One is discontinuous chips, another one is continuous, another one is continuous with built-up edges at various stages, depending upon the material is an hard or a soft or a ductile or a malleable. Whatever it may be, the different materials can be moved by these form. Fundamentally, these three types of chips are produced. That is, they are discontinuous or segmental form, continuous or ribbon type, or the continuous with a built-up edge. First one is a discontinuous or a segmental form. It consists of an element fractured into fairly small pieces. The discontinuous chips are also called to be in a segmental form. It consists of an element fractured into fairly small pieces. This type of chip is obtained by machining. Means a discontinuous type of chip is when is obtained in machining a brittle material such as a cast iron and brass. Next one is an continuous or a ribbon type chips. It consists of an elements bonded firmly together without being fractured. Metal flows by continuous ribbon type. Means in this type continuously chip is without break can they produced. It's called to be a continuous or in a ribbon type chips. Another one is in a continuous with built up edge. This means the term builds up at various levels at various stages is called to be a built up edge. The term builds up edge means building up of a ridge of metal on the top surface of the tool above the cutting edge. Means is some in a segmental or another type some built is formed is called to be a built up edge chips. Next one is an next topic is move on to orthogonal and oblique cutting. These are the fundamental two types of cutting are employed. One is in two-dimensional, another one is in three-dimensional cuttings. Is called these are one in two-dimensional cuttings or in orthogonal cuttings. Only 2 points are contacts between the workpiece and the tool, or in a that is a knife edge in a directly perpendicular to the 90 degree to their axis is called to be an orthogonal cutting. Another one is an oblique cutting is in a three-dimensional cutting. Touches the tool workpiece. Commonly, V tool is employed in oblique cutting. In fundamentally in orthogonal cutting, when the cutting force of the tool is 90 degree to the line of action or path of the tool, so it is called to be an orthogonal cutting or two-dimensional. Only two faces are touched onto the workpiece. Another one is when the cutting face of the tool is 90 to the line action or in a path of the tool, then it is called an oblique cutting. Is a three-dimensional cutting, and in this phase three faces of the cutting edges touches the workpiece. Next is the fundamental differences. The next topic is an orthogonal and oblique cutting. Orthogonal cutting tool travels in travel in the direction perpendicular to the cutting edge. In oblique cutting edge travels making an angle with which the normal of a cutting edge. In an orthogonal cutting, the cutting edge clear either end of the workpiece, and in an oblique cutting, the cutting edge may or may not clear either end of the workpiece. Next point is a chip flows in the direction perpendicular to the cutting edge in an orthogonal cutting, and a chip flows making an angle with a normal to the cutting edge. Is only two in orthogonal cutting, two mutually perpendicular cutting force acts on the workpiece, so it's called to be an orthogonal cutting. And another one is an oblique cutting, three mutually perpendicular forces are involved, and three mutually perpendicular forces are involved in an oblique cutting. These are the fundamental difference between the orthogonal and oblique cuttings. And that is about what about this class we discussed about the cutting tool nomenclature, and another one is a single point cutting tool. The single point cutting tool, and that is about the orthogonal and oblique cutting. These are the instructions very important in and is followed in the workshops also to produce the component at various stages and at various levels. That's all about the difference between the orthogonal and oblique